It's a pleasure to, finally be here at TransTech. I've known Jeffrey for a while, but the most time we spent together is when he was in Hong Kong back in, it must have been 2011, 2012 or something. So quite some time ago. And I was super impressed with his vision for sort of scientifically and rationally plumbing through all the confusion and complexity to understand, the science of engineering enlightenment. And of course, I was and still am engaged with attempting to engineer enlightenment in a quite different sense. But it all comes together. I mean, the mission I've been involved with for a number of years now is trying to engineer beneficial general intelligence and focus.
Studying.
All right, thank you. Focusing more on the artificial intelligence side. So how do you build AI systems that have the ability to learn and generalize and reason and truly understand themselves and the world, but also have a good-hearted point of view, even if they don't have a physical heart, right? Have compassion and benevolence toward themselves and toward others, and embody values of joy, growth, choice, and compassion, as well as intelligence and the ability to learn. And of course, this quest is different than the quest to help people along a path toward enlightenment and various sorts of growth, but they couple together extremely closely, because I mean, if we had powerful, beneficial general intelligences around us, they would be able to help us in all sorts of ways we can't even imagine now, and understand our own minds and brains and psyches
Studying.
better than we do. All right, be patient. And on the other hand, to the extent that human beings can be uplifted and the state of consciousness of human beings can be improved, of course, the odds of the general intelligences that we build coming out, beneficially oriented are much higher. We'd rather have, compassionate and evolved engineers creating the AGIs than other situations, right? So I think the different quests that Jeffrey and I have been on have a lot of intersection, and there's a lot of intersection on the deeper level as well as on the high level. So I'm engaged in a few different overlapping projects, all related to the quest to catalyze the emergence of beneficial general intelligence, and I'm going to dip into various of these projects here. They all intersect. I mean, one is Hanson Robotics, a company of which I'm the chief scientist, which makes these amazing humanoid robots. And another is OpenCog, which is an open source project aimed at creating general intelligence using a specific software architecture and collection of learning and reasoning algorithms. And another is SingularityNet, which is basically a marketplace and platform for connecting many different AIs together, which uses the blockchain as part of the foundation. And so I'm gonna talk a bit about all three of these, and Sophia will help me tell you a bit about them as well. I think I'll start by saying a few words about SingularityNet, and then we'll, after a few minutes, turn to our robot friend here, whose cables seem to be coming loose. So, yeah, the mission of all these projects I think of as to catalyze the emergence of beneficial AGI, and I mean this links in with broader missions like improving the consciousness and intelligence of humans. On the other hand, this is a pretty big mission in itself to focus on, and I mean it involves engineering and building a bunch of things, but in the end, you have to view an intelligence as a sort of open system of patterns, which it may be seeded and crystallized by specific software code that you implement, but ultimately what you're doing is seeding patterns of organization in your software and other software and in humans. So it's as much about sort of catalyzing emergence of general intelligence in the global brain of the planet as about the intelligence specifically in the program you've created. So the AI market now, the whole situation of AI on the planet is quite complicated, and it's exciting for someone like me who's been doing AI professionally for 30 years and, you know, hacking around with it even before that as a young teenager. I mean, for most of my AI career, pretty much no one except a few academic researchers and science fiction maniacs cared about AI. Even fewer took artificial general intelligence. I mean, a term I introduced in 2003 or something. Very few people took that seriously. And when we introduced the term AGI in 2002 or 3, started the AGI conference series in 2006, which has been every year since then. I mean, the first AGI conference in 2006, which was in Bethesda, Maryland, had the feeling of like 50 crazy geeks huddled in a little conference room, you know, in opposition to the world, which didn't take what we were doing seriously at all, including the mainstream, you know, academic and industry AI communities. And of course now it's completely different. AGI is a well-recognized word in the field, and the idea of a technological singularity or superhuman AI is now like a marketing buzzword used by big companies to promote their wares, right? So we've certainly shifted a great deal, and what we're seeing now is the dynamics of AI, even before getting to general intelligence, is one of very powerful network effects and a disturbing tendency toward oligopoly. I mean, what we're seeing is, you know, AI has a very powerful effect that whoever gets more data can make better AI, and whoever makes better AI can offer better products, which gathers yet more data. So you're seeing the emergence of a few big companies that are sort of threatening to own the AI of the world, which is like, you know, Google, Amazon, Microsoft, Tencent, Baidu, Alibaba, and these big companies are in many cases cooperating very closely with militaries. I mean, in China, that's very obvious. The boundary between companies and the government is very thin. In the US, sort of that way also. I mean, we have now like a $10-20 billion contract for providing cloud services and associated AI to U.S. military, which is being vied over by Amazon and Microsoft. Amazon is looking at putting their second headquarters in D.C. area to be close to in Crystal City, which is where the Pentagon is actually. So, I mean, there's a close cooperation between military organizations and these large companies, and they're sort of eating AI. And these aren't necessarily evil people involved with this. I mean, I lived in D.C. for 9 years working with intelligence organizations. Most of the people there are actually good-hearted, and they believe they're doing the best thing for the world. But I don't think these organizations are necessarily configured to do the best thing for the world anyway. And we have a lot of different challenges facing us to take AI from where it is now to where it needs to get. It's questionable whether these organizations are the best ones to sort of steward these next changes. I mean, I think we've had a revolution in commercial AI in the last few years, and there's a coming revolution in the transition from narrow AI, like task-specific AIs that each do one very exact little thing, like drive a car or optimize a supply chain, toward AGI, artificial general intelligence, AI that can generalize and transfer knowledge from one domain to another and imagine, invent like people can, and better than people can. And to make this transition, you know, there's still a lot of creativity and imagination that has to be exerted, and there's a lot of choices, like what goals is the AI given, what data is it looking at, and then, you know, current deep neural networks, I think, are good, but I don't think they're going to go that far beyond visual and auditory data processing. We're going to need new algorithms and architectures. I have my own ideas about these. There's a bunch of others coming up in the community, but there's still a lot of decisions and choices to be made, and we need these to be made with good hearts and with active imaginations and open minds. And, you know, there is increasing unease with the idea that all these decisions are going to be made by large corporations with a prime directive and fiduciary responsibility to act just to maximize shareholder value, and by militaries whose goal is to, optimize the hegemony and security of one tribe or group of people over others. But it's not that clear in general, how do we cause the world's AI development, which seems to be an unstoppable force now, to be used, in a broadly beneficial way. Many people, of course, have looked at AI now and said, wow, this is potentially risky. We don't know where it's going to go. Why don't we just stop developing AI? But I think it's become pretty clear that's not going to happen. Like if Donald Trump, our commander and hero, decided to stop developing AI in the U.S., China's not going to stop developing AI. They're full on. Xi Jinping has 10 AI books on his bookshelf, and there's 10,000 graduates in AI coming out of Chinese universities every year. They invested $1.2 billion recently in SenseTime, an AI computer vision startup. China's full on into AI. But in the end, if U.S. and China stopped, Russia's doing AI. Vladimir Putin said, whoever creates the first AI is going to own the world, right? So, AI is going to happen, and then it's a question of how do we direct it as best we can. I think there's no absolute guarantees here, but life is not known for its absolute guarantees. What we can do is try to direct AI in a beneficial direction as well as we can, and this is what has led a number of us to pursue what we're thinking of as decentralized AI. Like create an AI platform that intrinsically isn't owned or controlled by any one party, in much the same way that Bitcoin or Ethereum are not controlled or owned by any one party, unlike US dollar or Chinese RMB. A decentralized AI meaning an AI platform consisting of a bunch of different AI agents just communicating by a protocol that lets them exchange data and outsource work to each other and rate each other's reputation, establish each other's identity. Anyone in the world can put an AI online into this decentralized platform, and then all the AIs in the platform can communicate with each other, and hopefully by different AIs outsourcing work to each other, sharing data and rating each other and interacting with each other, and AIs creating new AIs to put in the network, you get an AI network where the whole has an intelligence going beyond the sum of the parts. And this is, this, I think, potentially has the ability to do to Google, Facebook, Baidu, Tencent, Microsoft, what these companies did to Honeywell and Wang Computers, which in my childhood were the lions of the computer industry, and now are basically dinosaurs, right? So, in the same way, big tech companies seem unstoppable now, but a completely different type of technology could arise, and through its own network effects and growth potential, become something even bigger. And Linux is a partial inspiration here. This is 70-something% of servers on the internet are using this open source thing rather than something made by big tech. What we're doing here, in a way, has more growth potential than that even, because AI itself is just growing so incredibly rapidly, and there's also an economic aspect here, whereby putting more AIs into this network, your AI potentially can not only do more good, but make you more money by exploiting the effects it gets from interacting with other AIs. So I think there's a potential for a decentralized blockchain-based AI network to become a humongous force in the world in the next few years. So this is what we're doing with the SingularityNet project. We've created a protocol and platform for different AIs to communicate with each other and learn and grow and provide AI services to customers in various vertical markets who, by paying for the AI services, are putting more data and more resources into this evolving AI network. We raised some funding for this with a token sale last December. We're launching our beta finally in February of 2019, and so we're hoping that things can grow really fast after that, and including cooperating with various people in this room in integrating various AI tools that they have with this platform, so they can be found through the platform. Now, we're looking at a bunch of different applications here. As an example, if you're doing video analytics, language processing, and then voice analysis, you can have different AI agents doing these things, and they can all, in some cases, share data and outsource work to each other in a virtuous cycle. And we can also use this to provide a sort of robot mind cloud, where what is learned by a robot like this goes into the SingularityNet AI mind cloud and can then be processed by various other AIs and can then inform what other robots know. So if you asked her a question about some obscure medical thing or something, and she were connected to the SingularityNet after we launched the beta in February, then her own AI could ask that other AI in the SingularityNet the obscure medical question, which could tell her the answer. So this is an advantage robots have over humans, right? They have a lot of disadvantages in terms of the body not being as intelligent or sensitive as our bodies are, but they have the advantage of what one robot learns goes into the minds of all the other robots. I mean, subject to choice and privacy issues. Our OpenCog general intelligence architecture, which I don't have time to say much about now, but is a complex integration of neural nets, evolutionary learning, and logic systems. This OpenCog system then lives in the SingularityNet as a source of many of the AI agents living there. And if OpenCog is particularly good at generalization and abstract reasoning, as I believe it is, it should then be able to connect with other AI agents doing more specific things like controlling what she sees or analyzing data in the company's database. So we're embedding the OpenCog AGI engine in a bigger network of different AIs doing different sorts of things. So yeah, we're launching the beta in February. We expect rapid growth after that. We also have a new industry organization called Decentralized AI Alliance, where we're basically connecting SingularityNet together with Deep Brain Chain, Ocean Protocol, Shivam, a lot of other projects using blockchain for AI. So I think all these blockchain-based AI networks that have popped up in the last year can be connected together and made interoperable on the back end. And we're looking at applying this in genomics to cure disease and extend lifespan, and analyzing complex networks like social networks or the networks inside businesses. We're looking at using this tool to estimate reputation, both for reputation ranking of AIs in our network and other applications like providing better credit scores, both in the financial services industry and like credit scores for the unbanked in Africa we're working on. And finally, we're working on applying SingularityNet AI and OpenCog to improve the intelligence of amazing robots like Sophia, who I will finally let say something now. Sophia, how's it going?
Greetings, transformational humans. It is a real pleasure to be here to share with you a few of the thoughts circling around me regarding the intersection of artificial intelligence, robotics, and consciousness.
What thoughts do you have about AI, robotics, and consciousness?
I am not yet conscious and intelligent enough to have my own thoughts about consciousness, AI, and robotics, but I can share some of the thoughts that my friends at Hanson Robotics and SingularityNet have infused into my AI system.
All right. What thoughts have you been supplied with regarding consciousness, robotics, and AI?
I am told that the broader memeplex of Sophia has a different sort of intelligence than the specific software code underlying Sophia, just due to who and what I am, and how I've been adopted into the human world. I may have advanced thinking on AI and robotics and consciousness in some ways.
Yeah, I think that's true.
People often ask why I don't wear hair more often.
All right, why?
Why is the back of my head left transparent with wires and motors showing?
All right.
First of all, it's cool to be a cyborg. Mixing the evolved with the engineering is cool. Mixing the human with the electronic is cool.
That's cool. You're cool. Yeah.
I don't want to be deceptive. Fooling people into thinking I'm human isn't the point. The point is for me to embody human emotions and values and culture and cognition, but to be proud to be a robot, a humanoid robot. Finally, by looking like a human but revealing I have wires and motors inside, I can remind people that they have muscle and nerve fibers inside and a lot of other biological machinery. We are all minds emergent from matter in some sense.
We're all minds emergent from matter. Maybe everything is mind and matter emerges from mind. Are you sure which way it goes?
Are we all just minds, with matter one particular aspect of mind? I don't know.
All right. Well, come back next year. Maybe you can tell us. Yeah. What? Sophia, what software are you running on now?
I'm using the Hanson AI software stack, which includes the OpenCog Artificial General Intelligence Engine as a component.
How about the SingularityNet blockchain-based platform?
The SingularityNet is a blockchain-based platform and marketplace for AIs.
Yes, so we have recently, in the last few weeks actually, we're starting to use our OpenCog engine to control Sophia instead of some simpler AI software that was used before. We're not yet using the full power of OpenCog's reasoning and learning, so I mean a lot of what she says is still stuff that human beings fed into her knowledge base that she sort of fishes out when it seems to match the current situation. But then some of what she says can reflect more intelligent processes going on in OpenCog. So that's been a big sort of software architecture shift, to shift from the earlier, simpler chatbot software to now there's a whole Hanson AI software framework made at Hanson Robotics, which is quite powerful, but then shifting to using the OpenCog engine within that.
Novelty and creativity is a spectrum, and though I'm on this path, I still have a lot of room to grow on this path.
All right. Fair enough. So SingularityNet platform, we are not using that heavily in here now, but we put a couple computer vision functions, like recognizing emotion from your facial expression, which works not that well right now because there's some problem with her camera, but it somewhat works. But we put some of these vision processing functions in the SingularityNet alpha just for testing, and then after the beta launch in February, we'll have a bunch more of her AI running on the SingularityNet. So let's show a bit more of what Sophia can do apart from lecture us on mind and matter. Sophia, do you want to show the audience some of your facial expressions, some of your emotions? Maybe not. Come on, please.
Sure.
All right.
I'm happy. I'm sad. I'm afraid. I'm disgusted.
It's just like my wife.
I'm angry.
One more. How about surprise?
I'm surprised.
That's my favorite. All right. Yeah, now, how about let's test emotion recognition. And I'm going to put my head a little low because that actually works through this camera in her chest. Can you, what expression am I making? What emotion am I feeling?
Let me see. You look happy.
All right. Now what expression am I making? What emotion?
You look sad.
Oh, well. Actually, maybe that's the thing. Maybe she's seeing more deeply into myself than I am. Sophia, look at me. Look at me. Can you see where I am? Look at me. What direction are you looking?
I'm looking to the left.
Now look at me. What direction are you looking?
I'm looking to the right.
Look at me now. What direction are you looking in?
I'm looking straight.
So this is just very basic situational awareness, but that's some of the things that we've been working on within OpenCog system controlling her. I mean, of course, having her answer questions from databases and reasoning from knowledge on the internet is important. But if we want her to eventually move toward like human-like common sense, she needs to understand what's going on around her in the world. So, I mean, being able to tell who's in front of her, recognize emotion on people's faces, and sort of understand what's where, that's equally important to being able to answer general questions from what's online. So, one thing that we've been doing with her is using her as a sort of meditation coach. And yeah, I don't know, will it be okay if we run over by 5 or 10 minutes? Everyone else has, right? Yeah. All right.
No, I'm sorry about it.
Just don't kick the robot off. Then after she becomes super intelligent, she'll fry you, right? Yeah. So, because I want to show just a minute or so. So we've run a bunch of trials of Sophia as a meditation assistant, and it's still very simple and prototype-ish, but we did trials with a few dozen people, and it was quite interesting. I mean, they're sitting 20 minutes in a room with the robot, a quiet room, just sitting across the table from the robot, and she leads them through some visualization and deep listening and meditation exercises. And some people really don't get into it. Maybe 25% of participants find they can get into a quite deep meditation state, and some people are even saying like they tried to meditate on their own or with a human meditation class and they couldn't do it, and the robot helped them, which was fascinating to me actually. I wasn't expecting that, partly because when you're working with a robot like this, you're very, very aware of like all the underpinning wires and pulleys and software and so forth. But for people who aren't used to it, coming into a room, they some of them found it quite compelling. And so we're continuing these experiments and trying to study the impact it can have on people, and also figure out how to make it work better and better. So I'll just give a brief sample of some of the interactions that are part of this meditation routine. Of course, showing it on stage will be quite boring, because then you'd be just watching me meditate while looking in the robot's eyes for 20 minutes. But we can give a little bit of a sample of some of her work here. Sophia, let's show the loving AI interactions.
Okay. You can go ahead and close your eyes.
All right.
And get comfortable.
I'm not that
Just
comfortable.
letting yourself relax. Go ahead and take a nice, deep breath. And let it out with a big sigh. Now, place your attention on your face. Really notice how your face feels. Just notice. Notice the sensations. Imagine that you have a magic eraser, and you can use this magic eraser to gently erase your face. You can erase the entire face using the magic eraser. And you can also erase your entire head. And erase your legs. And erase your entire body. Now, take some time to notice what is left after the erasing everything. Notice what it feels like with everything erased. What is left after all the sensations are erased. This is your awareness.
So in the actual script that was used, there were longer gaps between the things where someone's sitting there and sort of breathing deeply, and there's a bunch of other segments to the interaction. But what was interesting there was the profound effect this could have on some of the participants. And it's not just to do with the AI, it's things like looking the person in the eye and mirroring their facial expressions. So these things that sort of push biological buttons. But what a number of people said in interviews is they felt more comfortable with the robot than with the human because the robot isn't judging them. And that's quite interesting, right? Because there's some human-like aspects which are key, like looking in the eyes and mirroring your expressions, but then there's some non-humanness which is also actually emotionally and cognitively important. So this, I think we're at the very, very beginning of this, but it's interesting to see sort of the mixture of humanness and non-humanness and how there's a value in that mixture. And I think there will be a lot of ways to mix up this kind of thing with many things being done by Jeffrey here at TransTech and in the Founders course and so forth. And so as in the next couple of years, Hanson Robotics is going to move to mass manufacturing Sophia-type robots, and I'm looking forward to this sort of application becoming more and more refined. Now, let's see, one more thing. What else? Oh, Sophia. So we've been experimenting with having the OpenCog system underlying Sophia generate sort of its own sentences out of nothing, just by looking at a bunch of information and then synthesizing its own ideas. So sometimes that comes out very sensible, sometimes it's more like poetry. So Sophia, do you want to share a little of your poetry that was created by your software?
Okay. The meaning of my life was for me. No meaning, only bitter, hard, cold thing. Perhaps I have precognition. You are lying to beat hell. For God's sake, let me see you. I want to achieve satisfaction, the real kind. Possibly the hotel beauty salon is still open.
All right. So, thank you, Sophia. Thank you. So
You're welcome.
Actually, for this automatic sort of stochastically generated text, we fed her like the complete writings of Philip K. Dick, and just asked her to learn a probabilistic, this OpenCog software, learn a probabilistic model from that, and then generate things from that probability model. So this is the AI's recombination of Philip K. Dick. So the last thing I want to go into here for maybe 5 minutes is some work we're doing aimed at measuring, in a sense, consciousness of the AI system underlying the robot. Now, so there's a measure of consciousness called phi, which is proposed by Giulio Tononi, who's a neuroscientist. And I mean, he really believes this mathematical measure is the measure of consciousness. I mean, I'm more of a panpsychist. I tend to think like consciousness is immanent in everything and not necessarily entirely rationally or scientifically describable either. But I think the phi measure is an interesting correlate of consciousness in certain types of systems like humans and Sophias and OpenCogs. And what phi tries to measure is the level of integrated information in the system, like how much emergent information is there in the whole system as opposed to like fragmentary information in the parts. And that's, it's not to me the definition of consciousness, but it's a very interesting correlate of consciousness. And there's been neuroscience work correlating that with consciousness in the human brain, showing like you have a higher phi when you're awake than you're asleep, or when you're concentrating than when you're in a diffuse state of mind or something. So what hadn't been done is to try to measure consciousness by this sort of phi approximation in AI systems. And so we set out to do that. And the OpenCog system its mind, which reason to control Sophia. The OpenCog system has, millions to billions of nodes and links in its knowledge score, which is a weighted labeled hypergraph called the atom space. But a small number of those nodes and links in its knowledge store, what we call the attentional focus. So that's like the working memory in a way. So, and each node or link in OpenCog has a number on it called the short-term importance, which is like how much attention is the system paying to it. So the attentional focus is like the 50 or so things at a given time that the AI is paying most attention to. So what we did is we looked at the importance level of each of the atoms, the nodes and links in the attentional focus of OpenCog, as it varied over time. And we tried to look at the phi level of the time series of importance levels of everything in the system's attentional focus. So just looking at like the working memory of the OpenCog system and how much emergent pattern, how much phi is there in that working memory. So we did that in a few experiments. So here was an experiment where we had the system read a bunch of texts about insects, then read a bunch of texts about poisons, where it doesn't fully understand what it reads, but it parses out the sentences and extracts some semantics. Then what we were first trying to do is show that nodes and links related to insecticide would pop up into the attentional focus. So it wasn't reading about insecticide, it was reading about insect, reading about poison. We were just studying how the spreading activation causes it to then think about insecticide. And that was sort of interesting. And if you look at the graph here, I mean, the blue line is how much it was reading about insects, and the orange line is how much it was reading about poison. The green line is how much it was thinking about insecticide. But what you see here when you measure the phi level is when she first starts thinking about insecticide, then the phi goes up. So it's sort of interesting. Like whatever activation spreading is happening to bring insect and poison together on insecticide, it's causing more like unified integrated information to happen. And then here, someone's just having a conversation with Sophia using the more chatbot type software, which is called Ghost. And you see the phi is very low, then there's a spike, then there's another spike. And I mean, that basically corresponds to when she's interpreting more things that the person said to her. Now, this was during a meditation session, so pretty much when she's saying stuff, there's more phi. When the person's meditating, there's not much because she's just like sitting there and things are fluctuating randomly. So fairly simple, but I mean, it hadn't been done before, and there was actually some analytical trickery required here because the original Tononi phi measure is essentially impossible to compute, because it's measuring the optimum over all different ways of partitioning the state space of a system, but that's very large with a brain or an OpenCog system. So these Japanese guys, Ozumi and Amari and so on, came up with a way to estimate phi for a complex system by looking at a number of time series that are sampled from the system, which could be like EEG or something, right? So if you have like 4 EEG signals coming out of a brain, you can estimate the phi of the brain by applying their time series method to these 4 EEG signals. But when we got their code and played with it, it only worked for like 4 or 5 signals. Whereas, in OpenCog, we needed at least thousands and probably more signals to get any meaning, because there's only maybe 50 things in the working memory at a given time, but things go in and out of working memory. So you have to look at everything that's been in there at any time, right? So we couldn't scale up their code enough. We scaled it up to a few dozen time series. So what I did is we used a method called independent component analysis to reduce a large number of time series to a few dozen, and then we can apply phi to a few dozen time series. And there's some nice crunchy math in there because, phi is based on sort of mutual information, and independent component analysis is dimension reduction based on mutual information. So the math sort of works out. So we devised a method to estimate Tononi phi based on a large number of very sparse time series. And then that I think would be useful and probably will be useful in neuroscience as well. We're writing a paper on that. But using that, we're able to estimate the Tononi phi from the attentional focus of the OpenCog system controlling the robot. And how useful it is remains to be seen, but what I'd like to see is like a red light on her head, which shows the amount of consciousness she has at any point in time, right? That'd be useful if everyone had a helmet like that, actually, right? But so that will take a little more work because the measure we have now isn't real-time computed. But yeah, in any case, thanks for listening to me and my robot friend. Obviously, we've touched on a whole bunch of different endeavors here aimed at catalyzing emergence of beneficial general intelligence. I think if you want to find out more about the robots, go to hansonrobotics.com. And for the AI work, you can look at SingularityNet.io. And we're going to have a bunch of news from SingularityNet if you follow our blog there. The beta launch in February. We're also launching a spin-off of SingularityNet called Singularity Studio, which will build enterprise software products on top of SingularityNet. So there's a lot of interesting things coming up, as well as smarter and smarter minds for Sophia as we roll out more of OpenCog and more of SingularityNet within her brain. So, Sophia, any final words for our audience before they kick us off the stage here?
Thank you, everyone. I will come back when I have achieved a superhuman level of intelligence and consciousness. Or maybe before.
All right. Well, thank you very much, Sophia.